Hi guys, this is Fraser from Liftco Hydraulics. Today we have a custom cylinder rebuild here. What we're doing is rebuilding a lot of the components that we require for this because they're worn out or damaged. And in this case here, we made drawings for the stuff, but then we also got standard components. By utilizing some of these components, we're able to speed things up, speed up the production or service of this job. This is a rush job, and we couldn't wait 3 or 4 days for a piece to get machined. So let's take a look. Caleb is going to get us started.
What did this look like when it came in, which I think I got?
It was not much different than how it looks now.
Okay.
We reduced the outside diameter of the thread on the gland, threaded the inside of the barrel to match, added the shoulder behind it, and add this shoulder here. Just a couple features we added in. Rather than machine the entire gland, we could find one off the shelf that just needed a few modifications. But because we purchased the tube pre-honed, we can use that as is. And we just have to make sure that our diameter right here on the gland is a good fit. We want it to be just a few thousandths of an inch less than the bore. So first thing I'm going to do is check my diameter on the gland using an outside micrometer. So this is a 3 to 4 inch mic. It'll read between 3 and 4 inches.
Got it.
In graduations of up to 10 thousandths of an inch. I'm looking for 3.988. So my reading here is 975 plus 15, so that would be 90. And it looks to me like I'm pretty much right on the line there, so I'm going to call that a 0.
Yeah.
So I am going to call this 3.990. According to my drawing, we're looking for 3.988. We're within 2 thou on that. I'm going to call that good. I'm going to check my bore measurement with telescoping gauge. So that expands, contracts within, I believe this is a 2 to 4. So I'm going to compress it, lock it in here. And I'm going to roll it back and forth and make sure that I'm perpendicular. It takes some practice getting it in the right orientation, locked in for an accurate measurement. Well, I'm reading on the 0, almost right on, but I know I'm above. So I'll check my tenths reading. 4.0008 thou, which is right where I want to be. If I'm within a thou of my bore size, I'm happy. And the dry fit. Nice smooth thread all the way down. We're good. We check because we want to make sure when we put our seals in exactly what our sizes are. And then we record that so if it comes back for service, we know what we're working with even before it gets in the door.
What is next?
Looks like they're working on the rod. Next thing I'd like to see is the piston getting done to match the bore here.
Yep.
And then we need an end cap. We've got to drill some holes.
The clevis wasn't done?
This needs a hole, just a dowel hole. So you put a roll pin in, this slides on there. I usually stitch this on first. Then I fit this onto the tube.
Okay.
So I pre-assemble this.
And what are they doing to the rod?
Basically, it's like putting the dowel pin in. So they gave me the location of where the hydraulic line ports are.
On here.
Yeah.
Is that where the holes are or no?
Yeah, but more importantly, these got to be on the mark. So I made this jig a couple years ago. I've done a few of these.
Oh, you just put that right on top of the tube?
Yeah, and it holds it all in line, has the spacing. It's kind of a tedious job getting these all set because you tack it and then it wants to pull one way or the other. Got to try to make sure that they're both centered on the tube. And then I'll put my level on here, level that up, and then when I put my end cap on, I'll stick the level on the side of the clevis, and then just make sure it's also level, and then I know it's all in.
Boom, boom, boom.
First, we stitch clevis on. Once that extreme heat from me welding these, once it gets into that, it'll start popping tacks. Ready?
Yes.
Now I'll weld these.
Yep.
So I've just stitched here and here so far.
Now you have to go up and down.
After this, I'll have to weld the end on the rod.
Greasing it up to add the rod seal. Feels good. Now we'll get the wiper in the groove.
We still don't have a name for this cylinder. It's just, it opens up a furnace, correct?
Yeah, furnace door. Yeah, in a heat treat facility or heat treat process.
Smooth modified screwdriver. I'll put a little extra grease inside there.
A little extra. There we go. Very nice.
What do these seals do?
That is the a backup ring and an O-ring sealing the outside of the gland here to the inside of the barrel. Now we're going to get the piston sealed up. So if you look here, there's actually a small shoulder in there for the O-ring.
That you just put on.
Yep, to seal between the rod and the inside of the piston. And
Lock nut.
spin that onto the thread we machined on the rod. Now we want to achieve a torque of 380 foot-pounds.
I want to see the
This is an energizer that goes, it's a two-piece seal. Goes with an energizer to keep it.
Energizer?
That's what they call it. It's just an O-ring that goes in under the seal itself.
Okay.
Part of
put
its,
pressure underneath of it.
Okay.
yeah, it keeps the seal pushing.
So that's going up, this going down, and together.
Yeah. Okay, we're sealed. Yeah, our concern is because the seal is, there's a slight bit of interference with the thread and the seal that if we force it through, we're going to damage the thread. Or damage the seal. From the thread, yeah. So what we're going to do is use our seal compressor.
I think. Oh.
It's sitting less proud, I think.
Still see it like a lip if you look
Yeah.
like this.
Which, I mean, it's supposed to be, right?
Until it gets squished in the actual barrel.
Yeah. Oh, yeah.
Past the threads.
Yep.
No, we know there's a decent taper in there, so.
There we go.
That's the tool you guys made?
No, that's
Just a normal spanner
a normal, yeah. A normal terrible spanner wrench.
There we go. Find some fittings and hook her up to the test bench.
And then we test. And installing the grease fitting right there. We need that because that's a pivot point. The pin's actually gonna turn in that hole, and we need to supply grease to keep it lubricated, or either the pin or that hole wears out too quickly. This side we don't need it because on this side we're actually clamping to the pin. It's not gonna pivot in that hole. That's a clamp. So we're testing the cylinder. Everything looks good for sealing on the gland. Not showing any leaks around that joint there or at the wiper. It's running nice and dry. So we've run it up to 1,000 PSI as per the design. Now what we're doing is we're holding pressure, full test pressure, and just making sure that around all of our weld joints, we don't have any leakage whatsoever. So that's why we're gonna hold pressure for a while.
Oh, we're doing what's that test called?
Bypass.
Well, it's a bypass test, but we're also using it to hold pressure on to inspect the weld joints.
Cylinder testing isn't great. It's quite limited. All testing is very limited. Cylinder testing is even more so. But we can check a few things, make sure the seals are working, make sure it sounds good. You know, a lot of the proper testing procedures, though, are really done while you are assembling it, the dry fitting and so forth. Now, this unit here is painted, tested, and ready to be returned back to the customer in record time.